Welcome to the lesson on Pythagoras Theorem. We begin by looking at some triangles. We want to compare the sum of the squares of the two shorter sides with the square of the longest side. In the first triangle, we find that the results are not equal. However, three of the triangles, the second, third, and the last triangle, have equal results. When we draw out these triangles, we find that they are right-angled triangles. So Pythagoras concluded in his theorem that in a right-angled triangle, the sum of the squares of the two shorter sides equals to the square of the longest side, also known as the hypotenuse. Now, in the proof of Pythagoras theorem, we can think of the square numbers as a square. And if we divide the squares into unit squares, we find that all the squares in the two smaller squares fit exactly into the largest square, thereby confirming that Pythagoras theorem is true. There are many other ways to prove his theorem. Let us now look at the use of Pythagoras theorem. We know that Pythagoras theorem also works for decimals and fractions. Therefore, we can use the theorem in a right-angled triangle to find the unknown side if we know the other two sides. So using Pythagoras theorem, we form the equation 4 square plus 5 square equals to the hypotenuse square. Then we add up the squares and take the square root to find the value of x. There are many uses of Pythagoras theorem. Here we see that it can be used to find the distance between 2 points on a graph. On the right hand side, we can see that Pythagoras theorem can be used in solids as well, as there are right-angled triangles on the surface as well as with the height of the object. We can use the converse of Pythagoras theorem to prove that a triangle is a right-angled triangle. For example, we first use the letters to represent the side so that we can identify the sides. Then we work out the sum of the squares of the two shorter sides, followed by the square of the longest side. If they are equal, then we can conclude that since AB square plus AC square equals to BC square, then by the converse of Pythagoras theorem, triangle ABC is a right-angled triangle where the angle BAC is 90 degrees. We do not use the converse of Pythagoras theorem when the triangle is not a right-angled triangle. For example, doing the same, we work out the squares and compare the result. Then in this case, since AB square plus AC square is not equal to BC square, we conclude that triangle ABC is not a right-angled triangle. And this is the end of the lesson. Thank you.